So 3, 4 kind of heads a new direction a little bit. It's not. It's very similar. But now instead of focusing so much on alternate interior, same side interior, corresponding, and alternate exterior angles, it's going to focus more on the lines, the transversal, the lines that we're working with. So parallel and perpendicular are the two main things that we're going to focus on. There's a few theorems. So I'm going to explain the theorems to you. The nice thing with these theorems is there's often another way to get to where we're trying to go as well. But these are helpful to speed things along. So the two theorems that we're going to focus on right now, Theorem 3.8, Theorem 3.9, you do not need to memorize a number, but these don't have like a name. It's not like the congruent complements theorem or the congruent supplements theorem. It's just Theorem 3.8. When you're trying to use them in a proof, you just kind of describe them. If you want to memorize that it's Theorem 3.8, that's fine. I think it's way more work to try to put a number with it than just explain what's happening each time. So here they are. The first one says, if two lines are parallel to the same line, then they are parallel to each other. Okay? I'm going to use you as an example. I need 3 people. Sure, come up. 3 of you. I don't care who. Okay, so stand right here, Kalia.
I'm the shortest one.
Sebastian, you stand right there, and London, you stand right there. Okay. Would you say that Sebastian and Kalia are parallel right now? Yeah, they're both standing straight up, right? Okay. Would you say that London and Sebastian are parallel right now?
Yeah.
Okay. Go sit down.
Excuse me.
What would you say about them then? They're parallel. It's the transitive property, right? If Sebastian and Kalia are parallel and Sebastian and London are parallel, then good job. Thank you, team. So that's what this is saying, right? If they are parallel to the same line, if they're parallel to Sebastian, then they are parallel to each other, okay? So A is parallel to C, even though it's not marked, right? A is not marked parallel to C. A is marked parallel to B, and B is marked parallel to C, but it's just like the transitive property. Take out the one that's in common, and what's left will be parallel, okay? So that's the first one. The second one, very similar. I won't make you do this because someone needs to lay down on the ground if we do this one that way. We're not going to do that. This one says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so if T is perpendicular to M and T is perpendicular to N, then what's true of M and N is they must be parallel. Do you see why? What kind of angles are these?
Right.
They're right angles. What kind that we've been talking about? Corresponding, right? And if corresponding angles are congruent, which all right angles are congruent, then the lines are parallel. Okay? So we can say that M is parallel to N if they are both perpendicular to the same line T. Okay? It's pretty simple, right? Yeah.
So would that always work? For example, say it's a line like that, but they're not corresponding. They're like same side or inside alternate interior, or something like that. Like, would they still be parallel even though, like, say they're on the top and then the bottom, right? They're alternate exterior.
Oh, like this and this?
Yeah.
Will they be parallel?
Yeah. What was
If they're congruent, if those angles are congruent.
And you would know they're congruent because alternate exterior.
They'd have to tell you. No, because you can't say, oh, those are alternate exteriors, therefore they're congruent, unless they've told you the lines are parallel, right? Remember the two theorems? The one day we did the original, and the next day we did the converse.
Mm-hmm.
So you either have to know the lines are parallel, therefore the angles are congruent, or the other way around, they have to tell you the angles are congruent, and then you can say the lines are parallel. But if they don't tell you parallel or congruent, we don't know anything.
But because you don't know what they would add up to, huh? And if it's just numbers. But I thought alternate exteriors are always congruent.
Like if they give it to you like this, if they give you say you have, this is 121 and this is 121, then we know the lines are parallel because the angles are congruent,
What
right?
if it was 1 and 8? Like, for example, that one.
Right. If this is angle 1 and this is angle 8, and they say, are they congruent? We know nothing right now because they haven't told us the lines are parallel.
But if you numbered it, it would be one vertical and then the other because of the same side, alternate interior, and then that alternate interior.
Right, but you're saying we know the lines are parallel then. Because the only way we know, say this is 7 and
That
6.
makes
The only
sense.
way we know 7 and 6 are congruent is if the lines are parallel.
So
This doesn't tell us the lines are parallel. So you can't assume. You know what happens when you assume,
So that's
right?
what we have to figure out if they're parallel or not. But if it doesn't tell us, that makes sense.
Right, yes. You're jumping back to 3, 2, that type of stuff in the lesson, yeah.
There's a lot of confusion.
Okay, example 1. It says a carpenter cuts like the picture below. Will the sides be parallel? So we're making a picture frame, okay? And these are the cuts the carpenter makes. If he puts these together, will this side be parallel to this side?
Yes.
Why?
Because they're congruent. And the ones are parallel because the 45.
Because they're congruent, they're parallel?
Yeah. Well, sorry. They're supplements of each other because, 45 and 45 add up to 90. And what you said before is both 90, they add up to 180, and those are supplementary, so they are parallel.
Okay, that's one way to get there, right? What he just said, that's not using the theorem from today, but it's using the theorem that we learned a couple days ago. This is 90 and this is 90. If same side interiors are supplementary, then the lines will be parallel. So yes, that's one way to get there. What's the way to get there from today's lesson? If two lines are perpendicular to the same line, then what?
They're parallel to each
Then
other.
they're parallel to each other, right? So because these are both perpendicular to this line up here, then these two lines will be parallel to each other. So yes, you can say that either way. Both are correct. I actually think the way Sebastian said is the better way because it gives you more options. But this is the way they're looking for in today's lesson because that's the theorem we're focusing on. So
How do
either
you
way.
show that? Like, how do you prove that you know?
So you could say yes, both sides, this is the way for today, are perpendicular to the same line. So, oops. So they're parallel to each other. Right? You're just stating the theorem. If they're perpendicular to the same line, they're parallel to each other. But like you said, you could say the top angles are same side interior angles, and if same side interiors are supplementary, then lines are parallel.
But that won't always work because say they didn't give us 45, they just gave us numbers, for example, and they said 1 and 2 are congruent, and then like 4 and 3 are congruent, and they say the reason show us, and then we'd have to show that they are perpendicular to the same line.
They don't have to be perpendicular. That's the thing. They could be parallel. Like, say it looked like this instead. If this was, let's say this is 80 and this is 100, those lines are still going to be perpendicular, or still going to be parallel, right? Because same side interiors are supplementary. So these would still be parallel, even though they're not perpendicular to the top. So that's why there's other options.
So we write the perpendicular line and say, yes, because the sides are parallel? Or the lines are parallel?
The lines are
because-
perpendicular to the same line, so they're parallel to each other. You're just restating this. Like you could write this word for word if you wanted to.
Two lines are perpendicular to the same line, so they are parallel?
To each other. Mm-hmm.
Perpendicular is they are across from each other?
Perpendicular means they form a 90-degree angle, right? So
Oh.
perpendicular and perpendicular to this line means parallel to each other.
But those one added to 90. Those aren't one. That's 80 and that's 100.
Right, this is not using this theorem. This
Oh.
method is using the one from same side interiors, right? Yeah, that's what I was saying. There's two ways you can get there. You gave me this way,
Yeah.
which is correct. The lesson is focused more on the other way.
I was a little confused.
Yes,
Thank you.
no problem. Okay, last theorem, and then a proof, because who doesn't love proofs? And then we're done. You're gonna love them, guys. In chapter 4, you're gonna love them. They're so good. They're so good. I agree. Hey, listen. I agree that these ones are not the best, but that's why we give you some time to like be introduced to them before we get to chapter 4. Chapter 4, it's the same steps over and over and over again. You're gonna get it, okay? We're gonna make it crystal clear. You're gonna get it. What? Yes. I'm not putting like 7 on your test right now, right? It's just this is the end of proofs? Oh, no. We're just getting started. Chapter 4 is all proofs, you guys. All proofs.
18 more weeks?
18 more weeks of proofs?
How many more weeks? Right?
No, I mean, chapter 4 is just a chapter where we focus a lot on proofs. And then they kind of dwindle off again. It'll be okay. Don't stress out. It's going to be all right. Thursday's a quiz, 3-1 to 3-4. Yes. The quiz does not have a proof on it. No. See, all this panic about nothing. Okay, last theorem. And this one really is kind of just rearranging the last theorem that we did. It says, in a plane, keyword, in a plane. I'll show you why it doesn't work if it's not in a plane. If a line is perpendicular to one of 2 parallel lines. So they tell us these are parallel, and they tell us this one is perpendicular. Then it has to also be perpendicular to the other line. Do you see why?
Yes.
Why?
I mean, if they're parallel, they have to be at the same angle. So they would be, if one's perpendicular, have to have the same angle.
Right. They have to be, if lines are parallel, right, corresponding angles are congruent. So what they're saying is, if we have this setup, then it has to be true that this angle is 90 degrees also, right? That's how we know they're both perpendicular, because if the one is perpendicular with parallel lines, the other one has to be perpendicular too, okay? Corresponding angles is really what you're looking at. So we're gonna do a quick little proof of that, and then we'll be done. Oh, I was gonna show you this. Here's why in a plane matters. You don't need to write this. I just want you to understand why it doesn't work in space, but it works in a plane. So it says, for instance, if 2 lines are parallel and a line is perpendicular to one of them, that would be like this. So this vertical is perpendicular to this. Is this vertical line perpendicular to this parallel line? No. So that's why it says in a plane, because in space it's kind of like the skew thing, right? You can go in a different direction with it. So just heads up, in a plane is why this one matters. Okay, let's take a look here. The proof. It says in a plane, in other words, none of that last picture that I just drew. C is perpendicular to B. Notice they mark that for you. Okay, C is perpendicular to B. B is perpendicular to D. And D is perpendicular to A. They want you to prove that C, this line here, will be perpendicular to A, this line here. So notice they're not touching in the picture, but lines go on forever. So they're saying if this kept going, prove to me that this angle right here is 90 degrees, is essentially what you're doing, okay? It's a very short proof. Are you ready? What's step 1? Given. Easy peasy. Okay, so we know all of this. I'm just going to draw an arrow to it because I'm not going to write it all out again. Okay, so that is given. Knowing that, can you tell me anything? So knowing that C is perpendicular to B and D is perpendicular to B. Think through the theorems we just learned. What do you know is true?
D
Sebastian.
is perpendicular to A. Or they're congruent.
They told us that. I'm
but
saying
C is congruent to A. C is parallel.
parallel. C is parallel to D, right? If we know they're perpendicular to the same line, then we know they're parallel to each other. So that's 2. C would be parallel to D. That's theorem 3.9 that we talked about up here. But like I said, you don't need to remember the name of it. You can just kind of reiterate what it says. So 2 lines perpendicular to the same line are parallel to each other. Okay? You can absolutely put through theorem 3.9 if you want, yes. Okay, so then the last step of the proof, feels like we shouldn't be done yet, right? But we are, is what they asked us to prove. How do I know then that C is perpendicular to A? Because D is perpendicular to A. Somewhat, that's part of it. These are parallel now, right? And these are perpendicular. So if you take the fact that they're parallel and perpendicular, that last theorem, which actually has a name, by the way, if you want to just remember that name, this one right here says if you have parallel lines and one set is perpendicular, then the other set has to be perpendicular too, right? So I know that C is perpendicular to A by the perpendicular transversal theorem. Now, if you want to rewrite the theorem out because you don't remember the name perpendicular transversal theorem, I'm fine with that, okay? That's up to you how you want to go about that. But this theorem right here is the reason that we know C is perpendicular to A. It's very transitive feeling, right? Perpendicular to perpendicular means parallel, parallel to perpendicular, and parallel to perpendicular means you're gonna have another perpendicular. It's kind of like one begets the other. Questions on that? And I'm telling you guys, I'm not putting any proofs like this. I know these are not the easiest proofs because there's just a lot going on. Chapter 4 is easier proofs, and you're not gonna agree with me the first day or two, but as we get into it, I promise you're gonna be like, yep, these are better than the chapter 3 or the chapter 2 proofs by far, okay? It will become a groove and you'll love it.